Here's a quick little experiment. I have a thermometer here. It's showing that air temperature in this room is about 20 degrees Celsius. I'm going to take this piece of tissue paper, which is soaked with propyl alcohol, and attach it to the end of the thermometer. Let's watch what happens. As you can see, only about a little over a minute of time has elapsed, but our temperature on the thermometer has dropped about 4 or 5 degrees Celsius, which is significant. The question is, why did this happen? The decrease in temperature that we saw on the thermometer is caused by the same thing that causes your skin to feel cool after you wipe a little bit of alcohol on your skin. After you wipe some alcohol on your skin feels cooler. You may have even noticed the same effect when you use hand sanitizer. When you use hand sanitizer, rub it on your hands will feel a little bit cooler afterwards. It's also the same reason why the drinking bird is able to work the way it does. And it all comes down to what we call evaporative cooling. This picture is going to help us understand how evaporative cooling works. In this liquid, you can see a depiction of the particles of liquid moving around. We know that they're actually packed much closer together than what is shown in here, but we also know that they can slip and slide by each other. Notice that there are different size arrows on these particles, indicating that not all the particles are moving at the same speed. Also, notice that some of the particles near the surface, like this one, are moving so fast that they get enough energy to actually break through the surface of the liquid and become a gas. That is the process of evaporation. So now let's think about how this works with evaporative cooling. As evaporation is occurring, only the fastest particles are leaving the liquid, meaning that the slower ones are left behind. It's also important for you to understand what temperature is. Temperature measures the average kinetic energy, or the average speed, of all the particles in a substance. So before any evaporation takes place, imagine all these particles of liquid moving at different rates. Their average speed is the temperature. But as evaporation occurs, the fastest particles are leaving the liquid, leaving only the slower ones behind, which means the average speed of the liquid's particles gets less and less, which means the temperature gets less and less. And that's how evaporative cooling works. So this is why our bodies perspire. Our bodies perspire in order to cool off, because we cool off when the perspiration evaporates from our bodies and cools us off. And dogs, they pant in order for that to happen. The saliva on their tongue is going to evaporate, and that cools them off. You have probably noticed that if it's a very humid day, that means there's a lot of moisture already in the air, and your perspiration is not able to evaporate as easily. So you stay really, really hot. Whereas on a low humidity day, your evaporation easily evaporates, your perspiration easily evaporates, and that removes heat from your body and cools you down. So let's explain how the drinking bird works. There is water, or in this case alcohol, in the little cup here, and that gets onto the bird's beak, which can retain a lot of that moisture on it. However, that alcohol or water evaporates off the beak, which in turn cools down the glass around the bird's head. This in turn lowers the pressure of the gas inside the bird's head, which allows
the green liquid to be forced from an area of relatively higher pressure to what is now an area of lower pressure. So the green liquid rises in the tube. When the liquid gets high enough in the tube, it makes the bird's head heavier and tilts it, and then the bird soaks up a little bit more liquid, alcohol in this case, or it could be water, and then the process repeats. You may have noticed that when the bird tipped over far enough, the liquid in the tube was able to travel back down to the bulbous end of the bird, or maybe we could say the butt end of the bird. But the process will repeat over again. We can watch it again and maybe speed up the film to show it go a little bit faster.